to 2/3 of today's material is kind of laying a background, looking at peritoneal structures, reviewing blood supply and venous drainage, and then we'll have a break and come back and start with the actual anatomy of the beginning of the gut, the mouth, and its accessory structures. And then tomorrow we'll do esophagus and stomach and part of the small intestine and finish it up on Tuesday. All right? We have 2 lab days. We have a quiz at the end of lab on Tuesday. So you have today and Tuesday studying the models, and then we have another quiz on the histology section. So you want to start working on the histology today because there's a lot of lab material. And we've gotten kind of lazy, not lazy, but used to just the lungs or just the kidney. There's a lot of different organs. They're easily distinguishable from each other, so it's not too difficult to say this is the pancreas, this is the liver. There's a couple of ones that are, like pancreas looks very similar to the parotid salivary gland, but remember the pancreas have the endocrine cells, the islets, so that's a big clue as to what you're looking at. It's just there's a lot of different anatomical structures and thus histology structures, so you want to keep up with that. All right, so we look at the process of digestion. It really has several component parts. We have to eat unless you have a gastric tube. And so that process of taking food into the mouth is known as ingestion. So today we're looking at the anatomy of the mouth. Starting on Tuesday and finishing up on Thursday, we'll come back to these structures and talk about the physiology. So what enzymes are made there, what hormones regulate it, what's the chemical activity that's taking place. Okay, the first part is just looking at the structures. Then we have digestion. And digestion is the breaking down of the food material into its smaller components. And there are 2 parts to digestion. One is mechanical. Okay, and the other is chemical. To illustrate that best, let's say that I have a big block of limestone that I want to chemically digest with hydrochloric acid. And if I put it in a bathtub, let's say it's a big boulder like this, and if I put it in the bathtub of hydrochloric acid, it's going to take a while for the hydrochloric acid to chemically break it down into calcium and carbon ions. What happens if I break that rock down with a hammer and then grind it into a powder and then pour that powder? That's a mechanical digestion. I haven't changed it chemically. It's still the same chemicals, exactly. So if I pour the powder into the bathtub, you're going to have to leave the room really fast because of all the chlorine gas that would be produced. But it's going to, chemical breakdown is going to occur a lot faster because of the increased surface area. So mechanical digestion takes place primarily in the mouth and the stomach. So with our teeth and with the churning activities of the stomach. And chemical digestion, even though some chemical digestion takes place in both places, the primary site is the mouth and the stomach. Primary site for chemical digestion is in our small intestine. And then we start to absorb the products of digestion. That takes place in the small intestine as well. We absorb water and some of our fat-soluble vitamins in the large intestine. But the primary site for both chemical digestion and absorption is the small intestine. And then finally, we excrete or defecate the cellulose that we can't break down, waste products from the liver that have been dumped into the intestine via the bile duct and so on. So this is the structures we're going to talk about anatomically. Now notice I just identified the processes of the gut itself, what we call the digestive tract. Food that is in your digestive tract is inside your body or outside your body? It's actually outside. It hasn't been absorbed yet. Okay? So it's certainly not considered to be sterile. And then we have accessory organs. So structures, this would be structures that are accessory organs. The reason we call them accessories is because doesn't actually pass through them. Now, as humans, we tend to accessorize, all right? We put on rings and chains and glamorize ourselves. Those are not necessary to cover our nakedness or to keep us warm or to prevent us from being arrested for indecent exposure. But the accessory organs, like the liver or the pancreas, you would die without them. Okay, so the term accessory has a slightly different meaning. All right, so let's do some preliminary material here. We're going to look at peritoneal structures. Where did we first talk about the peritoneum? Anybody remember? Pardon? Well, back in 430 you learned about the membranes, and the peritoneum is one of the serous membranes, but in this semester we discussed it in reproduction, where the peritoneum formed the perimetrium of the uterus, and the ligaments, the mesosalpinx and mesoovarium and mesometrium. All right, so this is a cross-section through the body earlier in development. And so if we look at this rather briefly, remember we had the longitudinal folding of the embryonic disc, and our mesoderm formed somatic mesoderm, which formed our skeletal muscle. So that's going to be out here. And it formed smooth muscle around the viscera. So the gut has smooth muscle. But the mesoderm also forms the mesothelium, or the serous membrane. So where that is attached to the interior body wall, it's going to form our parietal peritoneum. And then it extends out to the gut and forms the visceral peritoneum. It's all serous. So skeletal muscle and parietal peritoneum. Smooth muscle and visceral peritoneum. So this entire space here then would be the peritoneal cavity. Now we had rather small defined cavities when we talked about the pericardial cavity or the pleural cavity. But if you look at a torso model like we have in the back of the room and the abdominal wall has been removed, so when you open it up and you see the glistening intestines, you're in the abdominal cavity. And again, the content of the abdominal cavity, like the content of the pleural or pericardial cavity, is going to be just serous fluid. Okay? So the organs are surrounded by the visceral peritoneum, but they're not in the peritoneal cavity actually. So now we have a double layer of peritoneum, simple squamous epithelia and connective tissue and blood vessels in between. And if you recall from our reproductive chapter, what did we call a double layer of mesentery? Double layer of peritoneum. Mesentery. Something I don't read your lecture exams out loud to you. So when we talked about the superior mesenteric artery and inferior mesenteric artery, those blood vessels travel between these two layers of peritoneum. Okay. So the next image I show, we're going to look at a sagittal view, and we have specific names for some of these mesenteric structures. So when we did reproductive, again, the mesosalpinx, the mesoovarium, and so on. Now, before we do that, in your reading, you might read about primary and secondary retroperitoneal organs. So if you recall from not too long ago, the kidneys developed from the intermediate mesoderm of the posterior abdominal wall. So they develop as retroperitoneal organs. They are always behind the peritoneum. Okay? The pancreas or the duodenum are examples of secondary mesenteric organs, whereas is intraperitoneal. And then in embryonic development, the intestines actually come out of the body of the embryo, rotate, and then come back in again, because the fusion hasn't yet occurred in that longitudinal folding. So they come out, rotate, and then come back in again. And so the pancreas, the duodenum are pushed up against the posterior abdominal wall, and that part of that visceral peritoneum is reabsorbed and disappears. And so they have peritoneum only on their anterior surface, and they're now considered to be retroperitoneal. So that's the difference. You don't have to know which organs are primary or secondary retroperitoneal, but I want you to know what that term means and what it is. So a primary organ always is. It develops from a structure in embryonic tissue that is always associated with the parietal peritoneum. Whereas secondary, it was intraperitoneal, it was surrounded by visceral peritoneum, and then a portion of that disappeared as the organ was attached to the posterior wall. You'll notice there's a ventral mesentery here, and I want to talk about a structure like that. Remember the ligamentum teres, the collapsed umbilical vein? Okay, so it's associated with the mesentery as well, and I'm going to diagram that in our next image. As we go through these structures, starting tomorrow, when we look at the stomach, I will be identifying structures that are intraperitoneal and structures that are retroperitoneal. It's pretty easy. It's almost every other one. So the stomach is intraperitoneal. The first part of the duodenum is retroperitoneal. The rest of the small intestine is intraperitoneal. The ascending colon is retro. The transverse colon is intra. The descending is retro. The sigmoid is intra. So it's in that sequence.
So when they're retro, do they not have any of the peritoneal?
Only on its anterior surface.
Only its anterior surface. So that's going to be the parietal.
Yeah. Well, if it's, yes, it will be considered parietal, but in its original, it was visceral.
So it's visceral. So what are we going to consider parietal?
Parietal.
Parietal.
You might find reading that calls it visceral because it's still associated with the organ,
Right.
but it's a continuation of the parietal.
Do we have that in our notes, what you just, that big list you just gave?
No, as we go through the organs, I'll be talking about it. So we're going to go back through each of these. All right, so this is the sagittal view of the body. And this is primarily to look at the different mesenteries and what they're called. You have a diagram of this in the preview material of your lab to practice identifying.
Does my booty look like that?
So this would be the diaphragm.
That's mine.
And we'll make this a female so we can give her a uterus. The kidneys should be here too, but they're not in the center of the body, so I'm not drawing them in.
Oh man. I gave mine a belly button.
All right, so liver, stomach, this is the transverse colon, and then the various loops of the small intestine. So I'm going to draw on parietal peritoneum, and then come back and do the visceral peritoneum and mesentery. Okay? So the inferior surface of the liver is covered with, of the diaphragm rather, is covered with parietal peritoneum. The superior surface of the diaphragm would be covered with parietal pleural. So both surfaces are covered with the simple squamous epithelium. I'm going to bring in our ligamentum teres here, so I'm putting a gap. And we separate the pelvic cavity from the abdominal cavity by the peritoneum. So it's draped over the bladder. It forms the perimetrium over most of the uterus, draped over part of the rectum. Covers the pancreas, which is a retroperitoneal structure. Okay? So this would all be parietal peritoneum.
What is the P in the middle of that on the circle book?
Pancreas.
Pancreas.
Then where it covers the liver, there is a bare spot in the liver, so I did that intentionally. It doesn't have anything on it. And now you see our first mesentery, a double layer of peritoneum. So on the liver, we're going to have visceral peritoneum, and we don't have any other specializations, just visceral and parietal like we did with the pleura. It's going to form a visceral peritoneum around the stomach. And then the anterior and posterior peritoneal come off and form a mesenteric structure that drapes down, and then it comes back on itself. So instead of a double layer, yes, instead of a double layer, we actually have 4 layers. And then that forms a visceral peritoneum around the colon. And then that is attached to the body wall as another mesentery. And then we have the mesentery supporting the small intestine is almost a little over 21 feet long. We come back like that.
Oh dang, I'm way too low.
So now let's label some of these structures. I labeled parietal and visceral peritoneum. This would be visceral peritoneum as well. I'm not going to label all of it, but if it's around an organ, it's visceral peritoneum. So this double layer between liver and stomach is known as the lesser omentum. This layer has quite a bit of adipose tissue in it. It's also known in layman's term as the fatty apron, because it can be lifted right off of the intestines. So this is known as the greater omentum. This one is smaller, this one is larger, but also this one comes off of the inner curvature called the lesser curvature of the stomach. And this one is attached to the bottom one called the greater curvature. So we use those similar terms.
Curvature of what?
The greater curvature of the stomach, I'll show it to you on an image. So now this is our colon. Notice that the greater omentum does not come back to the stomach. So when we lift that, and I'll show you in some images from Netter's atlas, when we lift the greater omentum up, we're going to see the inferior surface of the greater omentum, not the stomach. We're going to see the inferior surface of the greater omentum and the colon. So as you lift this up, you can see how that's going to still cover up the stomach. Now the colon is attached to the posterior abdominal wall, and so it's the mesentery of the colon. Because it's the transverse colon, this is identified as the transverse mesocolon. Then the small intestine, remember I said, was about almost 21 feet long. And imagine an anaconda or a 20-foot python, a snake. And you lay that out on a sheet, and you pick up the two edges of the sheet. That would be the mesentery, those two surfaces of the sheet. So say that my forearm here is this part of the small intestine. My sweater is the peritoneum. So I suspend it like this would be visceral peritoneum, and these double layers would be the mesentery. Okay? So for the stomach, for the small intestine now, I've got 20 feet of mesentery that I'm suspending that small intestine with, that has to all be gathered together and attached to the posterior abdominal wall. So actually is literally gathered, forms a ruffled attachment. And that structure is known as the root of the mesentery. And then as it fans out to the intestine itself, those different surfaces are known as the mesentery proper. I have a diagram like this on your lecture exam, by the way.
Hint, hint.
So is the root what connects it to the...
I'll show it to you on the image now. So the root is where it attaches to the posterior abdominal wall, and all of this would be mesentery proper.